Hey everyone, here's a quick and easy sheet here and video just to explain how this tool works. This is something that I created myself all around. It's the way that I think load velocity profiling should be done, and I've called it the 963 protocol. What you may have seen out there is in literature and maybe in some articles are people creating a load velocity profile with 2 to 3 sets, maybe 40% of their max, 60% of their max, and then that's it, or 60 and 80 and that's it, or 40, 60, 80. I like the 40, 60, 80. However, I'm looking at an entire set of reps, not just the best speed, which is definitely one way to do it and valid. I think this is more valid and more trustworthy of showing in a real life situation, if I'm predicting somebody's max or profiling somebody's strength types, I want to be sure that I'm looking at not only how well they can do something one time, one rep one time, but multiple reps. So let me zoom in here and that way we can get a little bit better look of how the sheet works. Choose or type in your known one rep max, name, and then minimum velocity threshold. And that's really it to start with. I mean, for me on the back squat, it's somewhere around 0.35, which is the slowest you can move the heaviest weight that you can lift, so 1 rep max. And that's really important to have pretty accurate. So if you actually do know this exact number, and if you've gone to failure with some velocity, then go ahead and type that in. But for the most part, you can't go wrong with 0.35 or even 0.40. But I've seen athletes grind out a pretty sluggish 1 rep max at like 0.25, which I wouldn't even consider that good of a lift anyway, so unless you're a power lifter. So 0.35 is pretty good. Once that's established, then you can kind of come into the blue cells and type in your loads. Notice what happens when I take those away. I don't get the metrics of velocity and things like that. And then this is where it just gets to be a little bit more cumbersome than your traditional load velocity profiling scenario. I actually require that you type in the average speed, speed and velocity. I'm always going to reference mean velocity, so we're not even going to talk about peak here. But what was the average velocity of the entire set of 9? All right, so doing a set of 9 with 162. Okay, my average speed is 123. My best was a 128, and my slowest was a 118. All three are going to be used to determine my load velocity profile. So I want to have all three involved here. Could I get away with just doing highest or just doing set? The answer is yes. I can still have some idea of a profile, but the way that I've built out this sheet, the more data, the better, and this is going to give you a really nice and trustworthy profile from across the board. So as far as you actually doing this yourself and walking to the gym or having your athletes do it, I'd recommend doing a set of 9, a set of 6, a set of 3 with these percentages as a warm-up. And then going back through it again and hitting that 9 again, that 6 again, that 3 again at these percentages. So you're basically doing 6 sets, and it ends up kind of being a nice workout. 963, 963. Now you have a really powerful and trustworthy representation of load velocity profile. Always take a peek at the R squared value. You want this to be 0.987 and higher. These aren't real data sets, actually. This is just kind of made up. So notice that if I were to go way off the wall here and type a 0.8, you might see the R squared value change quite a bit, as it's not really matching up with the other data sets. So it didn't really change too much, so that's good. But you'll notice that happens as the data is removed. So anyway, area under the curve, the novel metric coined by Mladen Jovanovic, represents the square footage, if you will, under your entire curve, which really powerful metric as you compare one cycle to another or one athlete to another, who really has more strength reserve. And then of course your velocity predicted 1 rep max, which is 403, knowing that the max is around 405. That's pretty close. I even provide a range here. So it's somewhere between 400 and 407 based on this data, which is pretty spot on. But it's not always going to be the case on a 40, 60, 80 type deal here, so that's up to you. So notice if you change the load, it will change the number here, or you can change it yourself, being that the load is going to be the primary driving point. So you can, if you do change this and do, if you want to do 35% grade, you can change this as well. I'll have that automatically set up to do so. But the power of this tool and this protocol will always be applying this method of a 963 at these zones. So I hope you find this helpful and interesting. And if you still have questions, always welcome to reach out.